Welcome back. In this lesson, we're going to look at the formation of sedimentary rocks. So sedimentary comes from the word sediment, and sediment is the deposited material usually at the bottom of a stream or in a pile of like sand, like a sand dune. So material that once was a part of a bigger rock or even a mountain that was weathered, broken down, or dissolved, and then eroded or taken away from wherever it was, normally by wind or water, and then deposited somewhere else. When it's deposited, then that material can be compacted, squished together, glued together to form a new rock. So this is basically a recycling of old material into new material. So let's look at some examples. Sediment is something that has weathered off of a bigger rock. So it used to be a large rock, say a huge mountain, and then little pieces of that mountain have fallen off for various reasons. And then those pieces or those fragments, the dust or the different particles that used to be part of a bigger rock, has somehow been eroded and carried away and then dumped somewhere. And as it is deposited, you end up with a pile of this material. That pile can then later be glued together or fused together to form a new rock. So a sedimentary rock used to be a different rock. In fact, sedimentary rocks can be of any types of rocks. They could be other sedimentary rocks that were worn away into fragments and then deposited and then glued together, lithified. They could be metamorphic rocks, they could be igneous rocks, they could be any types of rocks, or they could be a mixture of all kinds of rocks that then are glued together to form a new one. So this is basically a Frankenstein rock. Okay, it used to be something else, fused together to make something new. So the first idea that we have to kind of understand before sedimentary rocks make sense is the idea of weathering and erosion. So weathering is the idea of breaking down a rock. So there's two different types of weathering. You can have physical weathering, where something is simply broken into smaller pieces. For instance, there's some ice in that first top picture. Water has gotten into the crack of a rock and then frozen, and ice always expands whenever it goes from liquid to solid. Okay, when water freezes to ice, it takes up a bigger space than the water did. Okay, because ice, if you know that ice floats on the top of water, it means that it's a bigger volume. That means it's less dense, and less dense means it floats. So when it tries to expand, it actually has enough force to crack those rocks open. Now, little parts might fall off first, smaller little slivers might come off, or huge boulders might break. You could actually break a rock into two parts. Okay, so this would be physical weathering. You can see the pile at the bottom of this cliff. So at the bottom of the cliff, you've got lots of detrital, essentially it's called detritus, or basically small fragments that has broken off and then formed an alluvial fan shape at the bottom of that cliff where little fragments have broken off and then eroded. Now, erosion is different from weathering. Weathering is actually breaking it apart. Then erosion is the idea that it falls off due to gravity and then is taken away, usually by water or wind or something like that. That would be weathering. Okay, so you can have weathering breaking it apart physically, like with water freezing into ice, or you could have chemical, where you could have maybe some acid rain. You could have some acid in the rainwater that then has a chemical reaction to that rock surface and actually dissolves some of that rock. Once it's dissolved, it carries away and falls to the bottom of that mountain or whatever. Or you can actually have weathering under the ground, where you could have rocks that react to acid, for instance, under the ground that form caverns or sinkholes or caves. Okay? So erosion, once something is weathered, erosion is the idea of taking apart that sediment somewhere else, taking it somewhere else. So usually it is it's carried away downhill by something called mass wasting. Essentially, gravity pulls that rock to the bottom, and then once it's a pile, something rains on it, the fragments go into the stream, and then the stream carries it away, something like that. That's erosion. Once it's eroded and it's in the water, so look at the picture there on the left, it's in the water, some fragments are so small that the water is actually dissolving in them, and then some are small enough that they're still rocks. The water hasn't dissolved that sand, but the water has enough energy to carry that sand. Okay, so it's moving along with the stream. And then some rocks are too big to be moved in the water, but the water can kind of bump them along the bottom. Okay, so that eventually the water is going to lose its energy, and that material is going to settle to the bottom of the stream. That's called deposition. It's depositing this material. And it has a lot to do with the energy. So fast-moving water, like if you think of a huge flood stage or like whitewater rafting, that's enough energy in that water to actually move huge boulders along the bottom of a river. Absolutely rocks. So falling in, say whitewater rafting, and falling in a raging river is not just that you could drown, but that you could be slammed in the head with these rocks that are moving along with the water. It's ridiculously dangerous. Okay. Lithification, lithoth is the Greek word for rock. So this is the idea that all these sediments are glued together. And there's two parts. You compact them, okay, so you squeeze them together so that there's very little air holes, little pores between them. And then something needs to glue in between. So sometimes it's water with minerals in it, and then the water evaporates, leaving the minerals, and the minerals act like a glue. Or some kind of a cement. In fact, when you want to have cement is these tiny, tiny particles that dissolve in water. If you were going to make concrete or cement, you put cement, which are these tiny little minerals that dissolve in water, and then you put some bigger rocks, and you put some gravel, and you put some sand, and it's glued together by these minerals that are dissolvable in the water. So it compacts and then cements. And it depends on what you have. Mud has tiny, tiny little particles, so it only has tiny little spaces. So any water in there would glue them together pretty well. Sand has bigger spaces, a little harder to glue them together because you have to have bigger amounts of glue, if you think of it. The minerals in that water would have to be bigger. Now, how they fall is called bedding. All right, so the bedding would be how they lay, and a lot of times that would be how it was deposited. How did the stream deposit it? So here's graded. Let's imagine that the big rocks come out of the stream first because they're heavier. Then the little rocks come out last because they are still being carried by the water and eventually laid down. So if you have stone that is big on one side, bigger particles on one side and smaller on the other, that's called graded bedding. Okay. The second kind of bedding, and you can see how it's bedding meaning deposited down on the base, is cross bedding. And cross bedding usually has to do with something that can change. Like imagine that the particles of sand from a sand dune, and the wind blows it, and then blows it a different way, and then blows it a different way, so that the particles are laying in different configurations. Then they stick together. Okay, so how that whole mountainside looks is called, in this case, cross bedding. The other thing here would be ripple marks. If this was at the bottom of a stream, if this sedimentary rock used to be dirt at the bottom of a stream, and that water actually moves the sand on the bottom of a stream, you've seen that happen, I have, in rivers, that can actually fuse that way, and you can get ripple marks in the rock itself. That used to be what the waves were doing to the tiny particles of mud on the bottom of that particle. Now, angular, if you have a rock that has angular particles in it, it means that they never were in a stream, because the stream will round it off. So as you go across, you can see that this has been in a long time in the water, because all of the bumps are worn off, the edges are worn off. If it's angular, it was either in the water a very short time or never in the stream, and then when it was glued together, you end up with angular pieces. those are called breccias. When you have rounded pieces put together, those are called conglomerates. Okay, so, and then how well sorted are they? Are they just one size, or are they a mixture of bigs and littles together? So as you're looking at these types of rocks, you're thinking, okay, were they round or not round? Were they all graded so that they're all either small or big? Or is it a mixture between them? Okay, so that is. And then the last here is talking about fossils. And some of these sedimentary rocks can hold, they used to be mud, and there might have been an organism, a living thing that died and then fell in that mud and then was lithified along with that mud. So it was preserved in that rock. As it became a rock, the evidence of that creature was sealed in the rock, and that's called a fossil.